Stratasys have been a market leader in 3D printing for around about 35 years, being the inventor of some of these processes as well. So, you know, we do believe we are number one in the polymer 3D printing market.
We're about to find out what type of 3D printing technology could really suit you and your business, and hopefully this could be a really good education for you. We're here at the Carr Fullen Group. Rob, you're from SYS, and we're going to be talking about technology that is built on Stratasys machines.
That's right, yeah. So here at SYS, we exclusively supply Stratasys 3D printers. Stratasys have been a market leader in 3D printing for around about 35 years, being the inventor of some of these processes as well. So, you know, we do believe we are number one in the polymer 3D printing market.
I'm actually quite shocked that you've said 35 years as well, because a lot of people might think this technology's only been around a few. And there's quite a variety. So let's split it up into 5 areas. Is that right?
That's right, yeah. So we've got 5 different technologies, 3D printing technologies, all polymer that we've got here at SYS. And I think, yeah, we're going to go through them individually now and just give you a brief few minutes on each one just to give you an update on that.
Yeah, to get some case studies and for you to understand exactly the benefits and where they kind of the strengths of that technology for yourselves. So let's start off with PolyJet, which is this area here.
That's right. So this is your parts here. So first thing that will jump out for you there is the colour, obviously, that's available with the PolyJet technology. PolyJet's a well-established technology. It's been around about 25 years now. It's an Israeli technology, and it jets down resin using an inkjet printing head. And the beauty of that technology is it allows us to spray different types of resin, different colours, different rubbers, different fields of resin. So you can see here we've got various different rubbers there.
It's kind of soft at the top and harder at the bottom. And I know you've used these. I mean, on The Apprentice, they've used these, haven't they?
That's right, yeah. So the latest series where they printed the toothbrush there, that was printed on the J850 machine, giving people a good idea of how quickly PolyJet can allow you to go from concept in 3D CAD all the way through to a very realistic 3D file.
And the textures and everything are so different. I mean, you look at some of these parts and it looks like a leather finish.
That's it. So, you know, straight out of Keyshot now, people can save a 3MF file. It's very straightforward. If you've already got colour parts and colour CAD files, then you can bring those out as a 3MF file and apply those straight into the 3D printer, and in a few hours you've got the part there.
The world is your oyster with this technology. And let's go on to FDM. So what is it? Fused deposition? Go on, you go.
Modelling. Nearly there, yeah. So fused deposition modelling, it's a very well established technology. That's one of the oldest technologies that we've got, and Scott Crump, the founder of Stratasys, invented that process 35 years ago. So that process allows us to extrude out material, varying different materials that we've got, layer upon layer to create the 3D part. Now the beauty of FDM is the strength and the material properties that we've got. So we've got a very reliable and repeatable process. We're printing within a heated chamber, which not a lot of people can do. We're also extruding materials such as the part there you're holding, which is nylon 12 carbon fibre, and that's got 35% chopped carbon fibre in the part. So for instance, just that material alone can be used for soft jaws as you're holding there, jigs, fixtures, masking aids, all sorts of things on the shop floor. We've also got a multitude of different other materials we can use on there as well now. And exciting news as well this year is that we're going to make the FDM technology, and specifically the Fortus 450, open material license as well, which opens up a whole new world of materials for people as well with FDM.
Wow. See, again, the world is your oyster. So a lot of machine shops are using these as well, like you say, with jigs and fixtures, holding different parts. And time is of the essence a lot of the time when you're making these parts as well, isn't it? You know, it's taken away from making maybe like mold tools or something.
Absolutely. So, yeah, no, range of applications does cover some of these different technologies. There is a bit of crossover there.
Right.
And what our expertise really is to try and help you understand which one of those technologies will give you the biggest benefit. And so, you know, 5 technologies actually allows us to do that now, whereas previously, you know, we only had the 2 technologies. With the 5 technology, it does allow us to be much
like
more
a blurred
consultative.
line. Yeah. SAF.
So SAF is a brand new technology. It's selective absorption fusion. And we've got a guy called Neil Hopkinson who works at Stratasys, who is the inventor of this technology as well.
Wow.
So this technology is ideal for low volume manufacturing, medium volume manufacturing. So it's a powder-based technology which is producing parts in PA11 at this stage, which is a real ductile, strong material. It's also got some sustainability benefits to it as well. And it's quite a tough material to work with in a 3D printer. So one of the reasons we've gone with PA11 first is because once we've tackled that, and now we've got a very consistent and repeatable process printing with PA11, it's very easy for us to bring more materials forward, the likes of PA12 and things like that.
What fascinates me with this technology as well is you can now produce parts that never could have been produced before in one. You'd have had to have machines, say, assemble, but now you can produce like this product. It's all in one, isn't it? Bar obviously the different colours, but is that one?
So these parts have actually been finished afterwards. So these have been dyed. So they're the same parts, but if you want a better finish, if your customer desires a better finish, then you can take these, you can tumble them, put them into a rumbler, you could bead blast them, and then you can dye the parts to get that colour there. So it really, the post-processing world for 3D printing is sort of something that's moving forward as well.
One example in the industry, where is this?
So, I mean, a good example of that would be in sort of the automotive world, where people are making these really high-value sports cars. If you've got parts on there that are going to be plastic moulded, you don't want to commit to that mould tool for 1,000 parts, something like that. So this is going to allow you to stack the build chamber, print off those parts and get cracking with it straight away. No mould tool costs.
Right, P3, program polymerization. Polymerization, right, and that's this area here, is that right?
That's right. So we've just got a few dental parts from there. I mean, it's not a dental specific technology, but we are seeing in the dental market people picking up the P3 technology because of its speed and its surface quality. I mean, you'll notice from some of these parts the surface detail is absolutely incredible.
Yes.
One of the benefits of this is that we can, again, use a variety of different materials. It's a completely open technology. So you can engage with material development companies and you can go down to very specific requirements for your materials. So if you need high temperature, if you need high tensile strength, you can engage with these people and they'll develop your material specific to that printer.
Fascinating. And to finalise, we're talking about SLA.
So SLA is a stalwart of 3D printing. It's a technology which you'll see in a lot of service bureaus where people are printing superb quality parts, as you can see there. So this is a technology which is, predominantly being used for prototyping, but also has got additive manufacturing applications as well. We see a lot of it in autosport. Formula One are a big user, for instance, of SLA as well.
I would say this previously made would be on like an injection moulding machine or something. Is that right or not?
That's right. I mean, in manufacturing, they'd be using injection moulding, but of course the big benefit is, for a part as big as that and as complex as that, you're not going to commit to a mould tool just for a one-off. So to get that surface quality, you're going to want a prototype, and that's where that really comes in. And for something like that, a lot of either internal service bureaus or actual service bureaus themselves would benefit from something like an SLA machine.
Okay, so Stratasys, of course, they provide all the machines that produce all of these, and there's some blurred lines in between each of these different technologies, but you're there to help. So why Stratasys?
Well, that's exactly why we're here, yeah. So why Stratasys? Stratasys, we do believe, are number one in the polymer 3D printing market. We've got a really, really wide range of technologies now, which crosses a lot of applications. And I think the reason to come to us now is because we've been here 15 years. We understand this market. We understand a lot of applications. We want to help people now.
And you're industrial. You're professional. That's where you are. You are on for industry.
That's absolutely it, yeah. So we're not aiming at the very low-end market, although we will engage with people who perhaps have had a bit of experience with those machines. And if you now think that you're ready for the next step, we can talk about trading those machines in potentially further down the line we get.
And you'll do complementary printing as well.
Absolutely. So that's an offer to everybody out there. If you want to take advantage of this technology and see if it's right for you, then contact us, talk to us about these different technologies, and we can offer to print you a free sample part.